Welcome to a lesson with Dr. Powell. Let's take a look at some more examples of matrix transposes. So let's remember that a transpose is something where rows become columns and columns become rows, something like this. And a transpose, if we restrict ourselves to a column interpretation, a transpose swaps domain and codomain. And in that swapping and the swapping of directions, um, we get this property that AB transpose is actually equal to B transpose A transpose. So it reverses direction of composition right here. Transposes are another way of expressing row interpretation in terms of column interpretation. So of course, um, order of functions would reverse in this case, just like this. So we can express um, how things happen in the row interpretation within the column interpretation itself. So we have this little property. We can just kind of memorize it if we will. Let's take a look at an example of applying it in this case. Um, Perhaps that A is a square invertible matrix. It has an inverse, so that A inverse is equal to the identity. The transpose of the identity is itself. Um, but using this idea right here, we reverse order. So A inverse would become first, then A, and then we put transposes in each part. Now notice one thing, A transpose times whatever this is equal to the identity, which means whatever this is the inverse to A transpose. This tells us something. This tells us that we can interchange transpose and inverse like this. Okay. All right, let's look at another example. What if we have something like AA transpose and we take the transpose of it? Right, we reverse the order, so we have A transpose transpose and A transpose. So that just, well, transpose is just itself again. A, this becomes A transpose. Well, notice that this transpose is itself. B transpose is equal to B. That's called being a symmetric matrix. Here's an example of a symmetric matrix where the first row is the same as the first column. The second row is the same as the second column. The third row is same as the third column. And you can see a symmetry across the diagonal like that. Okay, here's another example of a symmetric matrix that uses the ideas that we've just discussed. What if we have this matrix right here and we take the transpose of it? One step at a time, we reverse the order. This stays in the middle, but A transpose comes over here, A comes over here, and we put transposes in everything. Transpose, transpose, this transpose, A transpose. So this becomes A, that's A transpose over there. The inverse and the inverse and the transpose can swap places. And then we just have transpose of this, and we reverse order and put the transpose on like that, and we get this. Notice that in the end, we get the exact same thing as what we started with, which means that this matrix right here is a symmetric matrix. Thanks for watching.